National Electrical Code Article 400.8 paragraph 5 explicitly states that flexible cords and cables are not permitted to be located above suspended or dropped ceilings. This is a firm prohibition, and there are no exceptions or modifications within the code that would allow for such an installation. It's imperative to adhere to this regulation to maintain electrical safety and ensure code compliance. Understanding the reasoning behind this rule is crucial for proper electrical installations. Flexible cords and cables, by their design, are not intended for permanent wiring applications or for use in concealed spaces. They are typically constructed with insulation and jackets that are not as robust as those used in building wiring methods like Type NMB cable or conductors installed in conduit. Factors contributing to the prohibition include, firstly, the potential for physical damage. Above suspended ceilings, flexible cords can be easily damaged by maintenance personnel, equipment, or even rodents. This damage can compromise the insulation, leading to short circuits, ground faults, and potentially electrical fires. Secondly, there is a concern about heat buildup. Flexible cords are not designed to dissipate heat as effectively as building wiring methods. When installed above suspended ceilings, where ventilation may be limited, heat can accumulate, potentially causing the insulation to degrade and increasing the risk of fire. Thirdly, accessibility for inspection and maintenance is limited. Electrical codes require that wiring be accessible for inspection and maintenance. Flexible cords installed above suspended ceilings are difficult to inspect and maintain, making it challenging to identify and address potential problems before they escalate. Fourthly, there's the issue of improper support. Flexible cords are not designed to be supported in the same way as building wiring methods. Above suspended ceilings, they may be improperly supported, which can strain the conductors and connections, leading to failures. Fifthly, the use of flexible cords in concealed spaces violates the intent of the National Electrical Code, which is to ensure safe and reliable electrical installations. The code mandates the use of appropriate wiring methods for specific applications and environments, and flexible cords are simply not suitable for permanent wiring in concealed spaces. Understanding the types of cables and cords is also very important. Flexible cords are typically used for connecting portable appliances, lamps, and other equipment to a power source. They are characterized by their flexibility and relatively light-duty construction. Examples include Types S, SO, SJ, SJO, and similar cords. Cables, on the other hand, are generally used for permanent wiring installations. They are constructed with heavier gauge conductors and more robust insulation and jackets. Examples include Types NMB, MC, and AC cables. When planning an electrical installation, it's crucial to select the appropriate wiring method for the application and environment. In the case of wiring above suspended ceilings, only approved building wiring methods should be used, such as Type NMB cable and C cable, or conductors installed in conduit. These wiring methods are designed to withstand the conditions encountered in concealed spaces and provide a safe and reliable electrical system. If you encounter a situation where flexible cords are being used above suspended ceilings, it's important to take corrective action immediately. This may involve removing the flexible cords and replacing them with an approved wiring method. It's also advisable to consult with a qualified electrician to ensure that the installation is compliant with the National Electrical Code and local electrical codes. The National Electrical Code is a comprehensive set of standards for electrical installations. It's updated every 3 years to reflect the latest advances in electrical technology and safety practices. Familiarity with the National Electrical Code is essential for anyone involved in electrical work, from electricians and contractors to inspectors and engineers. It's also important to be aware of local electrical codes, which may be more stringent than the National Electrical Code. Local codes may address specific conditions or hazards that are prevalent in a particular area. Compliance with both the National Electrical Code and local electrical codes is crucial for ensuring electrical safety. In addition to the prohibition of flexible cords above suspended ceilings, the National Electrical Code also addresses other aspects of flexible cord usage. For example, Article 400.7 specifies the permitted uses of flexible cords, while Article 400.8 lists the prohibited uses. It's important to be familiar with these requirements to ensure that flexible cords are used safely and appropriately. Some of the permitted uses of flexible cords include connecting portable appliances, lamps, and other equipment to a power source, providing power to temporary wiring installations, and extending circuits for specific applications. Some of the prohibited uses of flexible cords include using them as a substitute for permanent wiring, running them through walls, ceilings, or floors, and concealing them behind building structures. When using flexible cords, it's important to follow these guidelines. Firstly, inspect the cord for damage before each use. Look for cracks, cuts, or other signs of wear. If the cord is damaged, replace it immediately. Secondly, do not overload the cord. Check the ampacity rating of the cord and do not exceed it. Overloading the cord can cause it to overheat and potentially start a fire. Thirdly, do not run the cord under rugs or furniture. This can trap heat and damage the insulation. Fourthly, do not use the cord in wet or damp locations unless it is specifically designed for such use. Fifthly, unplug the cord when it is not in use. This will prevent it from being accidentally damaged or overloaded. In conclusion, National Electrical Code Article 400.8 paragraph 5 is clear. Flexible cords and cables are not permitted above suspended ceilings. Understanding and adhering to this rule, along with all other relevant electrical codes, is paramount for ensuring electrical safety and preventing potential hazards. Always consult with a qualified electrician if you have any questions or concerns about electrical installations. Furthermore, it's important to consider the broader context of electrical safety when discussing specific code requirements. Electrical safety is not just about complying with the National Electrical Code. It's also about adopting safe work practices, using appropriate tools and equipment, and being aware of potential hazards. Some important electrical safety practices include, firstly, always energizing circuits before working on them. This is the most important safety precaution you can take to prevent electrical shock. Secondly, using insulated tools when working on electrical circuits. Insulated tools can help to protect you from electrical shock if you accidentally come into contact with a live wire. Thirdly, wearing appropriate personal protective equipment, such as safety glasses and gloves. Safety glasses can protect your eyes from flying debris, while gloves can protect your hands from electrical shock and burns. Fourthly, being aware of the potential hazards in your work environment. This includes identifying potential sources of electrical shock, such as overhead power lines, and taking steps to avoid them. Fifthly, following lockout/tagout procedures when working on electrical equipment. Lockout/tagout procedures ensure that equipment is de-energized and cannot be accidentally re-energized while you are working on it. Sixthly, never working on electrical equipment when you are tired or distracted. Fatigue and distractions can increase the risk of accidents. Seventhly, if you are not qualified to work on electrical equipment, do not attempt to do so. Electrical work can be dangerous, and it's best left to qualified professionals. Staying informed about electrical safety is an ongoing process. Electrical codes and safety practices are constantly evolving, so it's important to stay up to date on the latest information. This can be done by attending training courses, reading industry publications, and consulting with qualified electricians. Remember, electrical safety is everyone's responsibility. By following safe work practices and being aware of potential hazards, you can help to prevent electrical accidents and ensure a safe working environment. Now let us talk more about the types of wiring methods that are approved for use above suspended ceilings. As mentioned earlier, Type NMB cable, MC cable, and conductors installed in conduit are all acceptable options. Type NMB cable, also known as non-metallic sheaths cable, is a common wiring method used in residential and commercial buildings. It consists of two or more insulated conductors enclosed in a non-metallic sheath. Type NMB cable is suitable for use in dry locations only and cannot be used in wet or damp locations. Type MC cable, also known as metal-clad cable, is another popular wiring method. It consists of 2 or more insulated conductors enclosed in a flexible metallic sheath. Type MC cable is suitable for use in both dry and wet locations and is often used in commercial and industrial buildings. Conductors installed in conduit provide a high level of protection for electrical wiring. Conduit is a rigid or flexible tube that is used to enclose and protect electrical conductors. There are several types of conduit available, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The type of conduit used will depend on the specific application and environment. When installing wiring above suspended ceilings, it's important to support the wiring properly. The National Electrical Code specifies the requirements for supporting wiring, and it's important to follow these requirements to ensure that the wiring is securely supported and protected from damage. Wiring should be supported at intervals not exceeding 4.5 feet and within 12 inches of boxes, cabinets, and fittings. Support should be designed to prevent damage to the wiring and should be suitable for the type of wiring being supported. In addition to supporting the wiring, it's also important to protect it from physical damage. This can be done by running the wiring through conduit or by installing it in a location where it is not likely to be damaged. If the wiring is exposed to physical damage, it should be protected by a guard or a barrier. Another important consideration when installing wiring above suspended ceilings is fire safety. The National Electrical Code requires that wiring be installed in a manner that does not contribute to the spread of fire. This can be done by using fire-resistant wiring methods and by sealing penetrations through fire-rated walls and ceilings. Fire-resistant wiring methods include Type MC cable and conductors installed in metal conduit. Penetrations through fire-rated walls and ceilings should be sealed with a fire-stopping material that is approved for the purpose. Furthermore, it's important to consider the potential for electromagnetic interference or EMI when installing wiring above suspended ceilings. EMI can interfere with the operation of electronic equipment and can cause data errors and other problems. To minimize EMI, wiring should be kept away from sources of EMI, such as fluorescent lights and electronic ballasts. Shielded wiring methods, such as Type MC cable, can also be used to reduce EMI. Finally, it's important to remember that electrical work can be dangerous. If you are not qualified to work on electrical equipment, do not attempt to do so. Electrical work should only be performed by qualified electricians who are trained in electrical safety and who are familiar with the National Electrical Code and local electrical codes.